Hi, this is a short video to help you get started with Assignment 3, Cepheid Variables and Cosmic Distances. For this assignment you will need the assignment handout and some graph paper, pen, ruler and calculator. You can use the graph paper provided with the assignment here, or you can do what I have done and use your own graph paper. So bear in mind that when you make your own graph on your own graph paper, you should make the graph look exactly the same as the one provided in the assignment. You'll see that there are two y-axes on the left, apparent magnitudes going from, at the top, 10 down to 17, and on the right, an absolute magnitudes going from -6 up to +1. And mark out the x-axis, the logarithm of the period p, going from 0.0 up to 2.0. Right. So the first step of the assignment is to plot the luminosity period relationship for Cepheid variable stars in the Small Magellanic Cloud. And those data appear in Table 1. So we need to plot out the data in Table 1. And just bear in mind, notice that Table 1 extends over the 2 pages of the assignment handout. So here is my start of my graph of the period luminosity relationship for Cepheids in the Small Magellanic Cloud, and I've plotted there the first data point from Table 1. So I have here the logarithm of the period p being 1.63, and that Cepheid variable in the SMC has an average apparent magnitude of 13.2. It's an apparent magnitude, so I must use the left-hand scale on my plot in apparent magnitudes. So for the first star here, logarithm of the period p, 1.63, an apparent magnitude of 13.2. You carry on with that, plotting all the data in Table 1 for the Cepheids in the Small Magellanic Cloud. And your plot will start to look a bit like this. Now here I have only plotted 4 of the points from Table 1. You must plot all of the data points in Table 1 in your assignment. Once you've done that, you draw a line of best fit, a straight line which you think explains pretty well, as best as possible, the points in your graph. And for those 4 points, I have this as my line of best fit. Now, because you will be using all of the data in Table 1, your line of best fit most likely will be different to mine. But I'm just showing you this as a quick example, so I didn't plot all the points. The next step is to start plotting the data in Table 2. This is the calibrated period luminosity relationship for Cepheids, for which we know how intrinsically bright they are. We know their absolute magnitudes. So here I've started plotting the first 3 points given in Table 2. Again, we have the logarithm of the period, along with, now, the absolute magnitude. So when we're plotting these data, we need to use the right-hand y-axis. So for the first point here, the logarithm of the period is 0. The absolute magnitude is -0.4. So logarithm of the period 0, absolute magnitude scale now of -0.4. And you continue on with this. So I've plotted the first 3 points, and the point way out there. I remind you, will be plotting all of the data from Table 2 on your plot. Then you will plot a line of best fit, again a line which explains as best as possible the data for the calibrated period luminosity relationship. Once you've done that, we are now going to measure the distance modulus, the difference between the apparent magnitude and the absolute magnitude of Cepheids having the same period. So we choose values of the logarithm of the period, and we measure the apparent magnitude of a Cepheid having that period of variation in the SMC using this line of best fit, and the absolute magnitude of a Cepheid having that period of variation using this line of best fit. Let's see how that works. So here I have chosen a value of 0.3 for the logarithm of the period. I've gone up and I've seen where that vertical line intersects my line of best fit for the period luminosity relationship for Cepheids in the small magellanic cloud. And because that is recorded in apparent magnitudes, I read off the value here on this scale. For the same value of period, I continue up my vertical line, see where it intersects the calibrated period luminosity relationship for Cepheids for which we know their absolute magnitude, and read off the absolute magnitude for a Cepheid having a period or a logarithm of its period 0.3, and we use this scale here. I set out my results like this. So a table with logarithm of p, the apparent magnitude m for a Cepheid with that logarithm of the period, absolute magnitude from our calibrated scale, the distance modulus, which is the difference between the apparent magnitude and the absolute magnitude. We then work out the logarithm of the distance, which is the distance modulus plus 5, all divided by 5, and then the distance in parsecs, which is 10 to the power of this value here, log d. So, for my value, set of values here at log p of 0.3, my Cepheid in the SMC has an apparent magnitude of 16.55. For my calibrated period luminosity relationship, a Cepheid with a logarithm of 0.3 for the period has an absolute magnitude of about minus 1.15. I work out the difference, and we call that the distance modulus, and I put that into my equation here for the logarithm of the distance. I get 4.54. I take 10 to the power of that value, and I get a value of about 35 kiloparsecs. Now, it's important to note that I am using lines drawn using only some of the data provided in tables 1 and table 2. So your lines of best fit will be different and your values here will be different. You continue through this process choosing more values of log p to repeat these steps, taking values of the apparent magnitude and the absolute magnitude and so forth. When you do that, it's important to evenly step through log p. Don't take a whole bunch of log p values here and then only 2 or 3 up here. That will bias your results. So step through evenly. Doesn't matter where you start. You could start at 0 or 0.1 or 0.2. It doesn't matter. And your step size really depends on how many values you want to take to form an average. So when you've taken many readings off your graph and you have a number of distance values, as part of your answer you will find the average distance. Work out the average of all the distance values that you've computed. In step 3, we're told that our calibration isn't quite right. So the calibration curve isn't quite right. We need to shift the distance modulus by a small amount, by 1.5. Now we don't need to plot anything more here, but I would draw up a new table of results where I have log p, apparent magnitude, absolute magnitude, and then this, the shifted distance modulus. This is where I've worked out the distance modulus by subtracting big M from little m, and then adding 1.5 to it. And I've called that sum S. And when I go forward on this table, I work out the logarithm of the distance using S, this value here, and then I work out the distance using this equation here as before. And you should find that the distance goes up. You can simply copy your values of 0.3, the apparent magnitude, and the absolute magnitude, but then you must work out the shifted distance modulus by adding 1.5 to your value here, and then working out from there on. And again, once you have all your computed values of the distance, give your average value as part of your answer. Right, things still aren't quite right. We have another set of data which you can use to get the distance to the SMC using the Cephids as a distance scale. And those data are in table 3. So on the same plot that you had before, with the period luminosity relationship between Cephids, 4 Cephids in the small Magellanica cloud, draw a third line or third set of data. Here I've used the dot and square symbol of data in table 3, and then draw your line of best fit to those data. And again, I've only plotted 4 points from table 3. You must plot all the data from table 3 and go through the process again. You can copy down the values of log p, the apparent magnitude that you've used up to now, but when you start filling in the absolute magnitude for Cephids of a given log p value, read off the absolute magnitude using this period luminosity relationship, and then carry on. Before, fill in your new table, and at the end give your average value for the distance to the SMC. Alright, hopefully that helps. If you have any questions, feel free to come and ask me, Nick Rattenbury, JJ Eldridge, or seek help in the physics help room.